Hi guys, hope you all are doing good. So in this today's lecture, we are going to learn the top 10 interview questions in DSA, which was asked in interviews. So if you are preparing for GATE exams or interview placements, or if you are preparing for semester exams or mid exams, this video is helpful for you. So if you are completely a beginner, don't need to get worried. I will explain everything. So these are the some top 10 interview questions in DSA. So without any delay, let's begin. So let us see the questions first. So the first question we are going to see is what is DSA? So this is a very simple question. Let us see what is DSA. So DSA means it stands for data structures and algorithms. It is a basic concept. So data structure means a way of storing data. So algorithm means a step-by-step method to solve a problem. Suppose, let me give an example. Suppose you have a library. Imagine a library. The way books are arranged is called data structure. The books is arranged in the shelf is simply known as data structure. The method used to find a book is an algorithm. So suppose if you have a library, the books are arranged in order. This is the books are ordered. This is called data structure. When you are finding some particular book, suppose you want to find a C programming book, the way you're gonna find is called an algorithm. So I'm going to give an interview tip that is companies ask DSA because they want to know how efficient you can solve problems. So let us move to the next question, that is what is difference between array and linked list. So the answer is array. Array means store elements in a contiguous memory allocation. So it is fast access using index, and it is fixed site in many languages. When it comes to linked list, elements are connected using pointers, and memory locations can be different, easy insertion and easy deletion. So example for array, let me move to the next page. So the main, suppose the example for arrays are 10, 20, 30 and 40. So the main drawback with array is it is fixed. So the memory size is fixed. So if you declared 5 elements, we need to declare only 5. If you declare 6, it gonna exist memory, means it can't store. So for linked list, it can store large amount of 10, 20, 30 and null. So this is the main difference between array and linked list. So let me give an interview tip using arrays when fast access is needed. So we use arrays when we need faster access. We use linked list when frequently insertion and deletion are needed. Suppose you are using word software. You are typing something, you use undo redo. So this is known as linked list. So the linked list concept is used in undo and redo. So this is the main difference between array and linked list. So what is stack? So this is also a basic question. So stack follows the rule last in first out. So a stack of, suppose the example for stack is a stack of plates. So the last plate placed on the top is removed first. So the basic operations are stack in push, pop, peek and display. So as I mentioned earlier, the application used for undo operations, function calls, expression evolutions. So this is all about stack. So next question is what is queue? So queue also follows the first in first out FIFO rule. So stack follows last in first out. So follows first in first out. So example for queue is people standing in a line. The first person enters the line leaves first. So this are the basic operations in queues are NQ, DQ, display and peak. So applications are printer queue, ticket booking, CPU scheduling. So the fifth question is what is time complexity? So time complexity tells us how fast an algorithm runs when input size increases. So I had also made about time complexity in my YouTube channel. You can check it out. So common complexities are big of one. In let me write. So big of 1, big of n, big of n square, and big of log n, and big of n log n. So this all comes under time complexity. So log n means logarithmic time complexity, big of n means linear, and so on. So this is about the time complexity. So what is binary search? This is also a lead code problem which is available on lead code. I had made a video on that also, you can check it out. So what is binary search? So binary search works only when a data is slotted. Suppose binary search only works when the data is slotted. It won't works when data is unslotted. Suppose when the data is 2, 9, 1, 6, and 7. When you see carefully, this data is not slotted. The binary search will won't work. So when binary search actually work, it works when data is slotted on it. Suppose 1, 4, 7, 9, 11, and 20. So this data is slotted. So this is in ascending order, this is in random order. 2, 9, 1, this is not slotted. This is slotted data. So binary search works here in this slotted array. So find the first, we need to find the middle element. In this, the middle element is, suppose let for the better calculation, suppose let me add another number 22. So now middle element is 9. So 9 becomes a middle number. So suppose our target is 11. So the target 11 is greater than 9. So we are ignoring this side. So this becomes our new array, 9, 11, 20, and 22. So again we are checking the middle number. In this case the middle number becomes 11. So 11 equal to 11. So we have successfully find our number. So this is how the the binary search works. So next you are seeing what is recursion. So recursion means it is used when a function call itself. Suppose you are counting from backwards. Suppose you are starting from 5 and 4 and 3 and 2 and 1 up to 0. Suppose you are counting stop up to 0. So the important term is the base case, the condition that stops recursion. Without a base case, recursion contains forever. Suppose this, when base condition stops when n equal to 0, suppose these values are n. So n starts from 5. So n continues up till it reaches 0. So it should be decremented n minus 1. So this recursion continues when n equal to 0. Without a base case, recursion continues forever. If I am not given, suppose n equal to 6, but initially n equal to 5. So the this condition will go to infinity because we have given n equal to 6, but we have the n equal to 6 and initially stop when n minus 1 when n equal to 0. That means the recursion will go on, keep on going when until it returns n equal to 6. So this is how recursion works. So now let's move on to the next question. So what's the next question is, what is hashing? So hashing stores data using key value pairs. Suppose student ID, suppose your student name, suppose the student name be Jack and his registration number is 123. So and another student name is John, his roll number is 183. So the benefits of hashing is very fast searching, very fast insertion, and very fast deletion. Suppose let us take an example of a university. Suppose new students will come and the graduate students will leave the university. So the university deletes the graduation students data from the university and adding the new data who joins the new university in that academic year. So this is how hashing works. So data structure using hashing is hashing hash table, and the average time complexity for is big of 1. So the next question is, what is tree traversal? The answer for a tree traversal is, let me move on to next page. So what is traversal actually? A tree is nothing but a hierarchy data structure. Suppose a, so this is our tree, A, B, C, and D, and E. So traversal means visiting every node. Suppose common traversals are, let me type pre-order. So pre-order traversal is for this. So pre-order means it starts from root and left and right. So in this condition, A is root. So we're going to write A. So again, the root node is B, and we are writing left and right DE. So DE. So and it comes C. So A is root and B, D are left elements and C is the right element. So this is the pre-order. So let me write the post order also. Post order and in order. So let me write in order. So in order for this tree is In order means here root and here left and here right. So the root element is A, and the left elements are D and E. So D and E, and the right elements are C only. C. I'm sorry. Oh, it's D E B also. So then the pre-order becomes, it's not like this. It's not the correct order. I made a mistake. So left element in the left pre-order B also is there. So we need to consider B. So now the in order become D, B, E, and A and C. A is the root element, I mean root node, and the C is right, and these elements are left. So now let us see post order. So the post order is the, let me see the graph again. What I'm, so now the post order becomes D E B C A. So that's I think correct. So this is about the tree traversal. So the last question for today is, what is dynamic programming? So dynamic programming is an optimization technique. So instead of solving the same problem many times, we save previous answers. Suppose let me for example Fibonacci series. The Fibonacci series starts from 0, 1, 1 again, 2, 3, 5, 8, and 13, and 21, and so on. So this Fibonacci series actually work the sum of two previous numbers. So 0, 1 is common, and we are adding these two numbers and it results 1. Again we are adding these two, it results 2. Again we are adding these two, it results 3. We are adding these two, it comes 5, and again we are adding this, and it gives 8. So this is about Fibonacci series. So it uses dynamic programming. So without dynamic programming, many repeated calculations. Suppose I have given 21. Suppose here 21. So if I want to find the next element in the Fibonacci series after 21, I need to calculate from 0. It is very difficult. It is very time-taking process. Dynamic programming store answers and reuse them. So it helps us to fast execution, less repeated work. So these are the some questions asked in interviews and in semester exams and mid exams also. I hope this video is helpful for everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.